Welcome to lesson 11.5, an introduction to the theorems. We already know about the central angle and the arc. The relationship between a central angle and its intercepted arc is that the measure of the central angle is equal to the measure of the intercepted arc. In this picture, the measure of angle 1 is equal to the measure of arc AB. If we have an angle that's on the circle, it is called an inscribed angle. We know the relationship between the inscribed angle and its intercepted arc. This is not an inscribed angle, but its vertex is on the circle, and it will have the same relationship. It is formed by a secant and a tangent line, and it will have the same relationship. Just like the inscribed angle, if the vertex is on the circle, the measure of the angle will be half of its intercepted arc. Or, conversely, the arc will equal 2 times the measure of the angle. So, for example, in this picture we have the measure of angle 1 is half of the measure of arc AB, and the measure of angle 2 is half of the measure of arc CD. Conversely, the measure of AB is equal to 2 times the measure of angle 1, and the measure of arc CD is equal to 2 times the measure of angle 2. If we have angles inside the circle that are not at the center, then we have to do something a little bit different. So if it is inside the circle, now this is not at the center, although it kind of looks like it is. It's to the right of the center of the circle. Notice that there's an angle here and an angle here. Those are vertical angles. Those are congruent. If it were at the center, then this angle would equal this arc, and this angle would equal this arc. That's not the case for this. Instead, this angle right here is equal to the average of these arcs. These angles are still congruent because they're vertical, right? So those are congruent. But the arcs don't match this. They don't match their angle that is inside the circle unless it's at the center. This angle matches the average of its arc and its vertical angle's arc. So the measure of the angle when it's inside the circle is equal to the average of its arc and its vertical angle's arc. So in other words, in this picture, the measure of angle 1 and the same measure for its vertical angle, since vertical angles are always congruent, is equal to half of the measure of arc AB plus the measure of arc CD. That would be the average of those two arcs. Add the measures of the two arcs up and divide it by 2. Now, I will always use this equation, even if I don't know the angle and I know the arcs. Super easy. Plug them in and multiply by 1/2 after I've added them, and I have my angle. But even if I know the angle and one of the arcs, I will start with this equation, because I could plug in my angle here, plug in my arc here, and then solve for the remaining arc. So we're not going to look at a converse relationship. We're just going to always use this formula whenever we have 2 of these 3 pieces of information. You either have the angle and one of the arcs, or both arcs, and you're finding the angle. Our last concept that we're looking at in terms of theorems is when we have a vertex that is outside of the circle. For example, when we have two secants, there's two secants cutting through the circle, but the vertex is outside of the circle. Or two tangent lines. Yeah, I know this and this are congruent, but the tangent lines, if they touch the circle, then we have the following relationship. It's going to cut the circle into a major arc and a minor arc. Here is the major arc and the minor arc. It doesn't cut the circle. There's other arcs when it's two secants, but there is a major arc and a minor arc. And so the measure of the angle will be equal to the difference of half of the difference of the measure of the major arc minus the minor arc. So you have to look at what arcs are intercepted there. In this case, there's a big arc of AB and a small arc of AB, and they make up the whole circle. In this case, there's a bigger arc CD and a smaller arc YZ, but both are formed by those secant rays. So for this one, we have that the measure of angle 1, I'm going to put, this is point X on the line, that the measure of angle 1 is equal to half of the measure of arc AXB minus the measure of arc AB. So take the bigger arc, take away the smaller arc, do half of its value, you'll know this X outside angle. For this one, the measure of angle 2, I don't know why I'm doing it in a different color, measure of angle 2 will equal half of the difference of arc CD and YZ. Measure of arc CD minus measure of arc YZ. These are the formulas that we're going to be using. Okay, here we add the two arcs and divide by 2. Here we subtract the two arcs and divide by 2. Here, it's just the arc divided by 2, and here the arc is the same as the central angle. That is the difference between when the vertex is at the center versus on, versus inside the circle versus outside the circle. You will need to use these formulas. You will need to memorize these formulas. Sometimes I will give you the two arcs and ask you to find the angle. Sometimes I'll give you the angle and an arc. You will still plug it into this formula to solve for whatever piece is missing. Tomorrow in class, you will have some problems that you're going to try with your group as sample problems, and then some that you will try individually. This concludes the coverage of these formulas from the theorems given in section 11.2, 4, and 5. Have a great day.